Hello everybody and welcome back to another visual pattern challenge. Here is our pattern today. Here's step 1, here's step 2, here's step 3, and your challenge is to predict the number of rectangles in step 4 of this swirling, confusing vortex. If you can do that, can you predict the number of rectangles in step 43? And could you write an equation that could be used to predict the number in any step at all? So that's the challenge today. If you'd like to accept it, pause the video and see what you can do. Okay, this is an arrangement that we haven't really seen before, this sort of vortex. And when you have a swirl like this, it has to keep getting bigger as it goes around because the new sides have to be bigger than the old sides to make a swirl like this work. So I guess what I'm going to do is just count the length of the sides of the vortex first. So we've got a 1 and a 1, and then so this one is 2 and 2. Oh, and then we've got a 3 and a 3. Okay, and a 4 and a 4. And let's see, there's where the 4 ends. So this should be 5. Yep, that's 5 and 5. Okay, I think I'm seeing the pattern now. And then we would add a 6 here and a 6 here. Right. So if we continue this as we go, it seems like you add 2 sides each time and they get 1 longer. So we would have a side of 7 for step 4 and another side of 7. So what would that be total? So 1, 2, and then 4 more would be 6, and then 6 more would be 12, and then 8 more would be 20, and then 10 more would be 30, and then 12 more would be 42, and 14 more would be 56, I think. So, that's 1 plus 1 plus 2 plus 2 plus 3 plus 3 plus 4 plus 4 plus 5 plus 5 plus 6 plus 6 plus 7 plus 7. That should add up to 56. So I'm going to predict 56 rectangles in step 4. All right. Do you have a sense of what kind of pattern this is? Is this a linear pattern? Is it quadratic? Is it something else? What do you think? My thoughts are this must be quadratic because it keeps growing. The amount it's growing by grows every step. So let's analyze this to make sure. I'll put the step number here and the number of rectangles. So in step 1, let's see, yeah, that is 20. And in step 2, then we added the 5 and the 5, so that's 30. And in step 3, we added 6 and 6, so that would be 42. And in step 4, we're predicting 56. And then we can take the difference between each step. 30 minus 20 is 10. 42 minus 30 is 12. And 56 minus 42 is 14. So we didn't get a constant in that first set of differences, so it's not linear. And then let's take the second set of differences. 12 minus 10 is 2. And 14 minus 12 is 2. Yes, so this is quadratic. So my hunch was right there. And this 2 means that it's just a plain old x squared for our highest term. Now, how to see an x squared in these patterns, that's a little difficult. The way they're arranged, it doesn't lend itself to having that kind of visual insight. These numbers are pretty big. The trick I think I'm going to use this time is to make a new chart, and I'm going to try to think about the biggest square inside each of these, the biggest perfect square. So let's just list out the steps again. And let's see, 20, that'd be 16, the biggest perfect square I can get out of that. So I'm going to write that as 4 squared. And what would that I'd need then? That's 16, I'd need 4 more. So 4 squared plus 4. How about in step 2? Yeah, I could get a 25 in there, so that's 5 squared. And that would leave 5 left over. This looks promising. And then in 3, could I get a 6 squared? Yeah, that's 36, and that would leave 6 left over. 36 plus 6 is 42. And in 4, I could get a 7 squared, that's 49. And yeah, that would be plus 7 more to get to 56. So this, when I rewrite the numbers this way, we can definitely see there's a pattern going on here. 4 squared plus 4, 5 squared plus 5, 6 squared plus 6, 7 squared plus 7. We just need to relate that pattern to our step numbers. And 4 is 3 more than 1, 5 is 3 more than 2, 6 is 3 more than 3. So it looks like we're adding 3 to this step number. So that'd be x plus 3, and then squaring it to get this first part. And then we're just adding that same thing again, plus x plus 3. All right, I'm going to run out of room here. I haven't left myself much. Let me FOIL out this x squared plus 3 over here. That would be x squared plus 6x, and 3 times 3 is 9. And then I've got my plus x plus 3, and I can combine these like terms. So that's going to be x squared plus 7x, and then the 9 and the 3 is 12. So I think our equation is this: x squared plus 7x plus 12. Let's test it on one or two of these. So that would be 1 squared plus 7 times 1 plus 12. So that'd be 7 times 1 is 7, plus 1 is 8, plus 12 is 20. Yeah, that's how many we've got in step 1. Let's try it in step 2. So it'd be 2 squared plus 7 times 2 plus 12. That's 14 plus 4 is 18, plus 12 is 30. Yeah, so this seems to be checking out. So I'm pretty confident that our equation is correct here. Y equals x squared plus 7x plus 12. And then to find the number in step 43, we're just going to plug 43 in for x. So y equals 43 squared plus 7 times 43 plus 12. And let's see, that's 1849 for the 43 squared. And 7 times 43, that's 280, and 21, that's 301. And plus 12 more. Let's see, is that 2,162, I think? Double check the math on that, but that's what I'm getting: 2,162 rectangles in step 43. Well, how did that one go for you, this swirling vortex? Was it confusing? Were you able to get 56 for step 4? Let me know. Thanks, everybody.